Hi everyone, my name's Preshayla and today we're going to be learning about longitudinal and transverse waves. The aims of today's session are to learn about features of longitudinal and transverse waves, know how to define them and recall examples of them. First, we're going to start with longitudinal waves. We use a slinky to help us understand these two types of wave. So if you imagine a slinky lying flat on a table and you push it at one end, we're going to get areas of spreading apart and close together. Now, the areas of spreading apart are called rarefactions and the areas of close together are called compressions. Rarefactions are areas of low pressure and compressions are areas of high pressure. They happen all along the slinky. We also have the amplitude of the wave, which is depicted by this black arrow here, as well as the wavelength, which is the distance between two rarefactions or two compressions. The definition of the longitudinal wave is that the vibrations are parallel to the direction of the wave. Now we know that the direction of the wave moves from left to right, and the oscillations are going from left to right. So we can say that they are parallel to each other. Some examples of longitudinal waves are sound waves, ultrasound waves and seismic P waves. Now we'll move on to transverse waves. Again, we use a slinky, but this time imagine moving the slinky up and down. It creates a pattern that looks like this. Here we have the amplitude of the wave depicted by this black arrow, which is the area from the equilibrium to the highest point or the lowest point. They're both equal. We also have the wavelength, which is the distance between two peaks, which is the highest point of the wave, or two troughs, which is the lowest point of the wave. Again, they're equal. The definition of the transverse wave is that the vibrations are at right angles to the direction of the wave. So this time, the direction of the wave is still left to right, but our oscillations or vibrations move up and down. So we can say that they are at right angles to each other. Some examples of transverse waves are ripples on a water surface, electromagnetic waves and seismic S waves. So now we've learnt the features of them, how to define them and recall examples of longitudinal and transverse waves. Thank you for listening to this session on longitudinal and transverse waves.